There are about 7 billion of us living on this tiny magical planet, but only a few can see the patterns in what others consider to be mere coincidences. Patterns that are hidden in plain sight. Physics is a science that seeks out these patterns. Let's start with a ball. Pretty easy. Next, a chair. Maybe a bit harder. Maybe a giant van? Maybe not. When you consider a classical object like a book, its properties are color, length, breadth, and mass. Mass of an object comes from its constituent atoms. But what about their mass? Consider this arc, for example. When I cut it in half and get a mirror image, it exhibits a symmetry. Peter Higgs was one among the few who were gifted at observing these patterns. His contributions concentrated on one property of an object, the mass. Mass of an object can be thought of as the resistance it offers to motion.
In 1964, Peter Higgs, with 5 other scientists, solved this problem by proposing the discovery of Higgs boson. He separated mass from these equations. According to his theory, mass of a body is a result of its interaction with a field, not this field. According to quantum field theory, fields could be imagined more like a surface of a pond. When we drop a pebble, ripples are created. Similarly, electrons create constant or varying ripples in electric field. Interaction of an object with Higgs field bends in and creates dent. Your interaction of a heavy object with the field is observed. Now a light object is used. This was concluded. But what gives object its mass? To know more about what we are made up of, we need to look deeper. Microscopes just can't zoom enough. Things like knife and saw are too massive. For the tiniest object like this tomato, there is a limit to which it could be cut down. One cannot go beyond that certain point. We know that colliding two objects would throw all their constituents out. To break their internal forces, we need more and more energy. This immense power is provided by LHC at CERN. This is the largest atom smasher contained in a circular tunnel with circumference 26.7 kilometers and at a depth from 50 to 175 meters. It is situated near Geneva between France and Switzerland. Its temperature is comparable to that condition after the Big Bang. Our pre-existing knowledge of the Standard Model helps us to predict what comes after the collision. Collisions happen at 40 million times per second. AI uses algorithms for predictions of constituents after the collision. Any difference in the experimental and expected value implies the existence of a new particle. However, results are quite short-lived. Particles if created quite instantly disintegrate to form energy in the form of gamma waves. In 2012, scientists at CERN discovered Higgs boson. A field associated with it is called as the Higgs field, which is found to be fundamentally different. Its value is same everywhere.